Good evening, everyone. So first of all, thank you, Australian Solar Council, for having me this evening. And today I'm going to talk about my experience in PV industry in Asia. So I'll introduce myself a little bit. My full name is Kanyawee. You can call me Bill as well. And I just finished my undergrad degree from UNSW last year in Renewable Energy Engineering. And during my degree, I got to do my internship with ABB Singapore and also a startup called 5B in Sydney. And I also conducted my thesis with them. And I was also part of the executive team in Women in Renewable Energy at UNSW. And early this year, I started my career in PV industry with Mott MacDonald, which is an engineering consulting firm, and I was based in Bangkok. I worked there for about 5 months, and then I got the scholarship to start my PhD in renewable energy, again at UNSW. So I will start with looking at global PV market trend, and obviously China has been leading in this market for a while already, like 5 years. Now, what really surprised me is Japan. I've got 90% of the projects I've been working on is Japan utility scale PV. And Japan has been leading for already since 2013 in the market, and it still continues to grow. And most of the projects that I work on is ranging from about 30 megawatt to 200 megawatt size. What I always have in my thought is that Japan has very limited land area, so it will be challenging for them of how they put those PV panels as a big size like this. Yeah. And when I look at centralized and decentralized, with the I will focus on Asia Pacific here. The trend is about half-half between centralized and decentralized, in contrast with Australian market where the proportion of distributed PV is higher than utility PV scale. But what IEA PVPS suggests is that for the developing country in Asia, the trend for centralized will be growing more than this, because they focus on energy generation rather than self-consumption at the household level. So, and also from my perspective, as I'm from Thailand, I can see that the grid is not quite ready or still weak to take in the high PV penetration. And also the countries where electricity prices are cheaper than the cost of capital cost of PV, they don't really see the importance of self-consumption. And now I'm going to talk about what's driven the market in this country that I've been experiencing. So first is Japan. They continue growing utility PV scale since 2012 that the government has started feed-in tariff scheme, and that boosts up the investment in utility PV. But now they've just announced that they will cut down the tariffs. So this will slow down the 2016 market a bit, but it's still growing. And next is Singapore. So when I was doing my internship in Singapore, I had a chance to follow up with the renewable energy framework of Singapore. And as they have land scarcity, so they pay attention to rooftop PV. With the ways that most of the housing and resident in Singapore is in form of high-rise building. So, and most of them are owned by government housing developments or departments. So the decision of installing PV panels is left to the building owner. So the term solar leasing business is quite popular there, but the term solar leasing is different from the rest of the world, because here they mean by the developer install the PV panels on top of the roof, and then the residents in that building pay by consumption of their consumption from the roof, and then at the competitive rates with the network price. But in the case that the energy is not enough, then they have the contract with Pacific Gas, which is the generator, the big generation there in Singapore, to supply the electricity when there's not enough sun. And for Thailand, we've used quota and PPA scheme to boost the investments. So this is only successful for utility and commercial sector, but still not much in residential. Haven't got much attention from residential. And this year they launched 100 megawatt pilot project for rooftop PV. However, the government said they will not pay any tariff for excess electricity that inject into the grid. So I think that might not work, but we'll see how far it will go. Yeah. So when I was at McDonald's, my main role was energy yield analyst. And this is what I usually see. The typical plant design I usually see, mostly from Japan. They have close row spacing, low tilt angle between 10 to 15, which is not optimum tilt angle at all for Japan. And they have very high DC-AC ratio ranging from 1.2 to 1.7. So when I have a look at this, it's completely opposite from what I've learned from university. It's not optimum design at all. But now, so I start to realize that the cost of PV module has gone down a lot, such that they don't really care about maximum yield that they can get from the panels anymore, but they looking into more gaining increased annual production with the same fixed cost. So basically the same amount of land, same inverters, but how to fit most of the PV as much as possible. So the technical challenge that we first have is optimum PV layout design in a very limited land area. One of the projects that I've been assigned for is the 200 megawatt PV farm in Japan. And that to be allocated into four sites. And then the clients got back to us. So that was the original design with 4 sites. And then the clients said that they couldn't secure one of the sites. So we only got 3 sites left. But we have to keep the DC capacity at the same capacity, so at the same size. So what we have to do is try to fit all those modules that was in the 4th plan and allocate it to the rest 3. And that was very challenging for us because the land was, the original design was like 0.8 hectare per megawatt, which is very tight. So the way that we try to fit all the modules, varying the row spacing according to the section of the slope of the land. And the next point is that in Japan, we have various slope and orientations within the park because they most of the projects turn abandoned golf course into PV, which is not ideal at all. So, yes, so we have a lot of challenge with analyzing slopes and orientation. Also, PV sys that was we use has the limitations in analyzing the slopes. It only takes up to 8 slopes, where our plants have about more than 18 slopes. And that makes the yield analysis less accurate. So now come to the benchmark of parameters associated with PV modules. As the technology has gone quite fast, but the benchmark or for example, the value of losses for cadmium telluride module is still not updated. We do receive these values from the module manufacturer in order to model the yield. But then we think that it's still not quite, it's like when it comes from the manufacturer, it's more biased than when we get from third party. So we will need to more work on that. And the next one is snow loss estimations. As in Japan, they experience very high snowfall, and some of the months, almost the whole month is covered by snow. And the model that we use is still not accurate enough to model the snowfall on model the snow loss. And one of the clients claimed that frameless module, which was they were using Trina Solar, and they released frameless module in the beginning of the year, and they claimed that they will have less snow loss and less soiling loss, but we don't know of what order of magnitude, but because there's no study done on that yet. We also experienced volcanic ash as soiling impact, as one of our plants was close to the volcano, and it started erupting, releasing ashes since 2015, so it got ashes catching on the modules. And the common practice in Japan is that they don't clean the module, so they let it naturally wash, and that impacts soiling loss quite a lot. And the last one is what we experience in Thailand is flooding. So this picture, maybe it's not very clear, but the rack height of this farm is about 3 meters high, because it's experienced flooding of about 2 meters water level, so they have to raise it up high. And in this picture, they're cleaning by using scaffolding to clean the modules. Yes. So now to continue in renewable energy, then I decided to do my PhD because I want to see renewable energy contributing in electricity as a power generation, as a common power source. I want to use my background in PV performance modeling analysis to characterize the PV output intermittency in order to enable the high PV penetration into electricity market. And lastly, I also would like to contribute to create the energy security for developing countries. And yes, thank you.
Thank you, that was fantastic. So as one of our future generation speakers, we're always excited to have young professionals here that sort of show us their motivation for the industry and also what they've already been working on, where they might go. So really excited to hear about your story. Thank you.